Today we're going to be going over some key things to consider whenever solving projectile motion problems. Okay, so the big thing about solving the projectile motion problems is that we're going to treat the horizontal and the vertical direction separately in order to solve for certain variables to plug into the other side. Okay, it'll make more sense whenever we actually do a practice problem. But first, for the horizontal direction, the important thing to note is that there is no acceleration, okay, in the horizontal direction, okay, because the force of gravity only pulls down. So gravity can't work on the object as far as the horizontal plane. So when solving for anything in the horizontal direction, only use the constant velocity equation. Okay, now in the vertical direction, the object is always accelerating, and it's going to be always accelerating at 9.8 meters per second squared down. Okay, so depending on how you set up your cardinal directions, if down is positive, you'd have positive 9.8. If down is negative, you'd have negative. Okay, and then we'll be using the 5 equations of kinematics in order to solve for the variables in the vertical direction. Okay, time is the most valuable variable whenever we're solving projectile motion. Okay, and the reason for this is because time doesn't have a direction, it's a scalar. So it can be used interchangeably within the horizontal or the vertical components. Okay, so big thing though, just make sure whenever you're using the quadratic formula to solve for time, only use the positive times. Okay, we can't have negative time. Okay, for maximum height, solving for maximum height. Okay, remember that your Vy, so your velocity of the vertical plane, is 0 meters per second because that's at the peak of your parabola. Okay, at the highest point, remember that your velocity is going to be 0 meters per second. Okay, and so you can use this to help you solve for the maximum height. Also, if we're on level ground only, oh, that was very wobbly. You can find the total time of flight and then divide that by 2 in order to get the time for that, for the maximum height. Okay, so that'll be practice problem number 1 will be on level ground. So solving strategies. Always draw a well-labeled diagram. This will just help you kind of understand the problem, understand what kind of problem that you're doing, if it's like level ground, if it is being projected up on non-level ground. You'll then make 2 columns, one for the horizontal direction, and that will only have 3 variables because you're just going to use constant velocity for that one, and then the vertical direction with the 5 different variables. So make sure the units match up. So if any of the units are not in matching up, make sure that you convert them before you start your problem. Okay, the biggest thing, stay organized. Write down what you're looking for and what equations you're using. Make sure you set up your coordinate system. So if up is positive, down is negative. If right is positive, left is negative, whatever that might be. Rearrange your equations if this helps you. If you're able to easily just plug in the values in the same order that the equation is, that's fine too. That's up to you. As far as number 6, this is up to you if you want to do it. I'm going to be checking your work mainly. So if you're using values that have been rounded, you'll still get a close enough answer. My big thing is keep 4 decimal places for these problems whenever you are going through the different variables. Okay, And then if you're stuck, try solving for other variables to help yourself along. So time, like I said before, is the best variable just because you can use it in both the horizontal and vertical calculations. Okay, so projectile motion problems can generally be sorted into one of three. Okay, and so like I said, we're going to start with type 1 problems. I'm going to kind of go over how the strategies of the type 1 today, and then the next notes will be the actual example, just because the actual example will kind of take a while, so I kind of want to break it into a few parts. Okay, so type 1, a projectile launched at an angle on level ground. So level ground means that our displacement in the vertical plane is going to be 0. Okay, because we're starting from the ground, it goes up in the air, and then we're back at the ground. So vertical displacement is 0 once it hits the ground. Okay. The max height occurs at half the range. Okay, remember range is the displacement in the x-plane. And this is also half of the time, the total time. Okay, and then also for these, because the parabola is equal or balanced, the initial speed and the final speed are equal. Oops. Okay, so whenever you're drawing the diagram for these, the things that you can kind of start out with, we have this is our initial velocity, so v1. Okay, and we're going to have the x. Okay, remember that we don't have an initial and a final velocity in the horizontal direction because there's no acceleration, so it's constant, so it's just regular vx. And then we have the initial velocity of y. Okay, and then we have angle of theta, our launch angle. The maximum height here is when it's the halfway point, so half of the total of the displacement of x, and also t equals half of the total time. Okay, so that's where the maximum height is. Okay, also important to note, this is where Vy, velocity of y, is equal to 0. Okay. This is our displacement of x. Okay, and then over on this end, we have our final velocity. We're still going to have the same Vx because there was no acceleration. And then our final Vy. Okay, and then the angle theta. All right, and for these equations, your V1y is going to be equal to your V2y. Okay, so your final and initial velocities are going to be the same because we have a level ground. Okay, so our variables that you're going to be solving for or putting down your knowns are going to be your dx, which is your range, okay, or the distance or the displacement in the horizontal aspect. Your Vx is your constant horizontal velocity. Okay, and delta t is your elapsed time. For your vertical variables, here's the 5 different variables. So we have the vertical displacement, and then we have the initial vertical velocity, the final vertical velocity, acceleration, okay, and remember this is gravity, so 9.8 meters per second squared or negative 9.8 meters per second squared, depending on how you set up your positive and negative directions, and then elapsed time. Okay, so to start, some of the problem solving strategies is solve for time, using the displacement for y, the total displacement, the vertical displacement is 0. Okay, and then you can find max height. Oops. Using the elapsed time divided by 2 because it's half of the elapsed time. Or you can find max height by subbing in that your final velocity in the vertical aspect is 0 meters per second, because remember at the peak of the parabola your Vy is going to be 0, okay, which is at the max height. Okay, so those are the notes that we're going to be doing today. Like I said, our next section of notes will be actually doing the problem.